All right, hi folks, this is Larry Massimino. I'm recording a short video for Module 5 in Math 181, and I wanted to go over with you a few of these concepts and do a few web-assigned homework problems as well. So this module has to do with something called cardinality of sets. So what we'd like to know basically is just how many elements are in a set. Well, here's a simple example. Let's say I'm looking at this set A here. Here's a set A. Well, the cardinality would be 4 because there's 4 elements. So if there's 4 elements in the set, another way we say it is say cardinality is 4, but we use this notation n parentheses A. So you could think n is really saying what's the number of elements in set A, right? So of course the answer is 4 here. All right, but besides finding just the cardinality of a set, we want to know what's the cardinality when you form the union or intersection or Cartesian product of different sets. And you might say, well, why do we want to know this idea of cardinality? What is that? How does that help us? Well, it turns out later in the course when we talk about probabilities, when we go to do probability calculations, we need to know the number of outcomes or the number of elements in a set because that number is going to be part of the probability calculation. So we're going to need to know this idea of cardinality for some future work we're going to do in the course. All right, well, there's something a little special about finding the union of the cardinality of the union of two sets, okay? So we want to know what is the cardinality of A union B. All right, now here's where we got to be a little careful. Well, let me come over here to set A. These are the set of students taking a math course. You might notice here the cardinality of set A is 5, right? There's 5 students here. Paul, Jim, Susan, Mike, Laura. 5 students taking math. What is the cardinality of set B? These are the students taking English. Well, I can see here in set B, there's Susan, John, Victoria, Jim. That's 4. So I want to know the cardinality of A union B. You might think, well, why don't I just take 5 plus 4 and get the answer 9? Well, turns out that's wrong. The reason is there's some overlap between these two sets. To see that, let me form the set A union B. So let me come up here and just form A union B. Well, you remember A union B means combine all the elements of both sets together, but you don't repeat any elements. So if I was to list out these elements in A union B, I'm going to list out all the elements in set A first. That's Paul, Jim, Susan, Mike, Laura. Now I'm going to add the other students from set B, but notice here Susan. I'm not going to add Susan in the union because I've already got Susan, because Susan was also taking a math course. So I've already got Susan listed in the union. I don't list Susan twice. Here's John. Well, I do want to list John. Here's Victoria. I do want to list Victoria. And here's Jim. But Jim is already in the union, so I'm not going to list Jim. All right, so this is the union. Let me count up. What is the number of elements in A union B? Well, if you count up 1, 2, 3, 4, 5, 6, 7, there's only 7, not 9. Why is that? Well, it turned out there were 2 students, right? Namely Jim and Victoria, 2 students that were in the intersection. So if I asked you, what was the intersection of A union B? Well, the intersection are those elements that show up in both. So A union B would have been Susan, Jim. So the number of elements in A intersection B would have been 2. So because of this possible overlap, when you form the union of 2 sets, we need a more complicated formula that you see here. So this is the formula for the cardinality of a union of 2 sets. Well, it says take the number of elements in set A. In our example, that was 5. Remember, those are the students taking math. plus the number of, plus the cardinality for set B, which is 4. Those were the students taking English. But then I got to subtract the number of students that were in the intersection. Well, the number of students in the intersection were 2. So I've got to subtract a 2 here. What I'm doing is subtracting the number of students that were taking both math and English, because I don't want to double count them. Remember, I already counted Susan and Jim as part of N sub A. So N sub A included Susan and Jim. But also N sub B included Susan and Jim in the count. So to avoid this double count, I've got to subtract these 2 students because I was double counting them. I counted Susan and Jim in the cardinality for set A, and then I also counted Susan and Jim when I was working on the cardinality for set B. So that's a double count. Well, I'm going to subtract out that double count. So that's what this subtraction does for you. It subtracts the double counting, and that double counting is exactly the intersection of 2 sets. All right, so this is the formula you need to keep in mind when working on the cardinality of a union of 2 sets, okay? Now, of course, you might have a scenario where there are no students taking both math and English. What if I had no overlap here? Well, if there was no overlap, if no overlap, oops, let me rewrite that. If no overlap, then the intersection is really 0. Right? There are no students that are taking both math and English. Well, when that happens, this goes to 0. So I can simplify it and just say, if I want to know the cardinality for A union B, I can just take the cardinality for set A plus the cardinality for set B. But this is only when there's no overlap. When there's no overlap, we use the word disjoint. So disjoint means there's no elements in common between these 2 sets. Okay, so you can use this as kind of a special case if there's no overlap between the 2 sets. All right, one other cardinality calculation we want is, what about the cardinality for the complement of a set? Well, oh, by the way, there's a typo here. This should be complement here. All right, well, here's what to think about. Remember, when you want to form the complement of a set, you need to know what the universal set looks like. Let me give you a quick example. Let's say the universal set is the set of all students in a college. So I'm just going to make up a small universal set. So here are these students: Jim, Mike, Laura, Sally, Paul, and Victoria, let's say. So imagine these are all the students in college. I want to know the set of students taking a math course. So maybe that's Laura, Paul, and Victoria. I might want to know the number of elements in the complement. Remember, the complement, we write it as A with that apostrophe. Sometimes we say A prime. All right, well, let me write out A prime. Well, you know A prime are the members of the universal set that are not in set A. Complement of set A really means find the members that are not in set A. It's almost like the opposite of set A. All right, well, I know Laura is in set A, Paul is in set A, and Victoria is set A. So these other remaining students are not in set A, so I'm going to put them in set A prime, the complement. So the complement is Jim, Mike, and Sally. All right, well, you can see the relationship here. If I had the number of elements in the universal set, it would be 6. If I had the number of elements in A, it's 3, and the number of elements in A prime is also 3. I should have actually made the numbers here work out to be different. Let me add one other student here just to make the numbers work out a little different. I'm going to add in Harry. Okay, so Harry is not taking math. Remember, these are the math students, and these are really the non-math students, those students not taking math. All right, well, in my new example, the number of elements in the universal set is 7, and the number of students in the complement is 4. I just wanted to make these numbers work out to be different numbers. So really what this says is if you want to know the number of elements in the complement, just take the number of units in the universal set and subtract the number of units in set A. Well, that makes sense. If you're taking the total number of students at the college, that was 7, and you're subtracting the number that are taking math, that was 3, your answer is the number of students that are not taking math, which is 4 students in this example. Okay? So sometimes you don't have to actually list out. I mean, I didn't have to list out this set A prime if I didn't want to, because I could have just kind of calculated the cardinality just using this formula. Of course, it never hurts to list out the set if you want, and that makes it a little more obvious what the cardinality is going to be. All right, so just remember, cardinality means you want to know the number of elements in some set that you're interested in. All right, let me mention one other item, and then we'll do a few WebAssign examples. Well, you might remember the Cartesian product. So here was an example we did last module. Here was a set A of different smartphones. Here was a set B of different memory capacities. And we formed the Cartesian product. Remember, you write a little x in the middle, A, xb is Cartesian product. Well, you remember what that means is you take each element in the first set and match it up with each element in the second set. So here's iPhone matched up with 64 gigabyte. Here's Galaxy matched up with 64. Here's Pixel matched up with 64. Then I'm going to take the next memory capacity, 256, and match it up with each smartphone. So you can see here, there's really going to be 6 elements. So if I think about the number of elements in this Cartesian product, there's 6. Right, here's 1, 2, 3, 4, 5, 6 elements. Well, there's an easy formula to calculate this. You just take the number of elements in the first set, in our example this was 3, and multiply by the number of elements in the second set, 2, and we can get 6. Okay. All right, well, folks, please watch this video here. This gives you some worked out examples. This is only about 5 minutes long, so this is a good video to check out. And then also down here is another good video on finding cardinality when you're working with a Venn diagram. We're going to go do an example like this in WebAssign. So let's do that, but please remember to watch these short videos. It's very nice to see these worked out examples with an explanation. So again, please check that out. All right, well, let me go into WebAssign because I want to show you a couple of the different types of problems that you might come across in WebAssign. Let's try to do maybe one of each different type of problem here in WebAssign. All right, so this is the Module 5 homework. All right, let's go to example problem number 1. All right, so this one is saying find the cardinality of set A plus the cardinality of set B. All right, well, this is going to be a simple one, I think, because all I have to do is add up the number of elements in set A. Let's see, here's 1, 2, 3, 4. So there's 4 elements in set A. How about set B? There's 1, 2, 3, 4, 5 elements in set B. So they're just asking me to add these 2 cardinalities together. Notice they're not saying anything about union or intersection here. It's just add up the 2 cardinalities. So 4 plus 5 is 9. All right, let's go to number 2. Number 2 is a little different because now they say how many elements are in A union B? All right, well, I can either do this using the formula, or I could just list out A union B and come up with the answer directly by counting. Let's do it both ways. So let's form A union B. Okay, so A union B. That means take all the elements in set A. That would be Dirk, Johann, Franz, and Sari. And now I'm going to also include all of the elements in set B, but remember, we don't repeat any. All right, well, I'm not going to repeat Franz because he's already in my union. I'm not going to repeat Sari. She's already in the union. But I do have to include Tina. I do have to include Klaus, and I have to include Henrika. All right, so that's A union B. Well, now I can just count up. For the cardinality, remember, it just means count up. So I'm just going to count up. Let's say 1, 2, 3, 4, 5, 6, 7. So the cardinality here is 7. All right, well, how about if I wanted to do this using a formula? Well, the formula says if you want to know the number of elements in a union, take the number of elements in A plus the number of elements in B, but you can't forget that you got to subtract out the number of elements in the intersection. So let's find that. What is the number of elements in the intersection? Well, the intersection is the number of elements that are in both sets, right? What's in common? So let me check it out. What's in common between set A and B? Well, I'm noticing Franz is in common. And I'm also noticing Sari is in common. So there's 2 elements in the intersection. So this is going to be 2. All right, now I can just plug in. How many students are in set A? Well, I can see here there's 4 students. So that's a 4. How many names are in set B? Well, I'm just going to count these up. It's a 5. How many are in the intersection? We just said there's 2. So this is 9 minus 2. Of course, I get the same answer, 7. Okay, so you can either list out the elements in the set, or you can really do it using the formula. Either way, of course, you get the same answer. All right. Oh, by the way, notice in this problem, they gave us set C, but there was no use for set C in this problem. So don't get confused or don't get mixed up, because sometimes, you know, WebAssign gives you some information that you're really not going to use in a given problem. So just focus on, you know, the information you need. All right. How about if we go to number 4? Number 4 says find the cardinality of B Cartesian product with set C. All right, well, I could try to list out B Cartesian product C. So I could take the number 1 and match it up with red. I could take the number 1 and match it up with green, etc. But I don't want to do that because that's going to be some extra work. I remember the formula is you just take the number of elements in set B and multiply it times the number of elements in set C. So that's easy. There's 7 elements here. And set C, there's 3 elements here. So 21. Right, if I was to try to list out this Cartesian product, I would have to write out 21 of these elements, which would take me a long time. Much easier to just use the formula for this one. All right, let's go and do a couple more. Let me come here to number 5. All right, well, number 5 is asking me to find the number of elements in A union B. Notice here on this one, I must use the formula because I don't know the actual makeup of these sets, right? They didn't tell me what set A is. They didn't tell me what set B is. All they told me is the number of elements. So I'm going to use the formula that says take the number of elements in A plus the number of elements in B, but you got to subtract out the number of elements in the intersection. Well, they really gave me all the numbers I need to plug in here. The number of elements in set A was given as 46. Number of elements in set B was given as 23. And the number of elements in the intersection was given as 8. So I could just work this out On my calculator was this 69 minus 8, so this answer here is 61. Let's go to number 6. Number 6 is very similar, but it is going to kind of give you different information, so you're going to need to use a little algebra. Let me write this formula down again. N of A union B is the number of elements in A plus the number of elements in B, but I got to subtract the number. Whoops, this is a typo up here. This should be A intersection B. All right. So let me plug in what they gave me. The number of elements in set A is 109. So this is 109. The number of elements in the union is 156. So that's this substitution here. The number of elements in the intersection is 49. And I don't know what the number of elements in set B is. That's the unknown quantity. Well, this is a very simple equation I can solve for the number of elements in set B. Let's see, 109 subtract 49 is 60. Now, of course, I'll just subtract 60 from both sides. And I'm ending up that the number of elements in set B is, I think that works out to be 96. Okay, so on this one, I had to use the formula that we discussed for the cardinality of the union. And they gave me different pieces of the puzzle, and all I had to do was plug into the formula and solve for the unknown quantity. All right, let's do a couple more. I want to show you some Venn diagram examples, so let's do that. Why don't we do one with a complement? Let's do number 7 here, complement. All right, well, this says find the number of elements in the complement of A. I know that means I got to take the number of elements in the universal set. Here they're saying, they're calling the universal set S. And then you subtract the number of elements in set A. All right, so I could just do this. Let's count up the number of elements in set and the universal set. Here it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it looks like. And now I'm going to subtract out the number of elements in set A. 1, 2, 3, 4. So it looks like this answer is just 7. I could have actually written out the set A complement, but I really didn't have to do that because I could just use the formula. All right, why don't we go, let's go to a Venn diagram example. Here's a Venn diagram example. All right, now, here's what they're asking me to do. They're asking me to look at this Venn diagram and fill in the blanks, but I've got to pay attention to this given information here. All right, also, I could click on this tab. If I click on this tab that says description, it's going to give me a little more description about the setup of the Venn diagram. All right, so you can read this over here. All right, so first thing, I have to understand what this Venn diagram is showing us. So let me kind of illustrate what this Venn diagram is. There's 3 overlapping circles. They're labeled A, B, C. Okay. Well, if you look at this very center part here, that very center part is the overlap between all 3 sets. So it's really the overlap for sets A, B, and C. Those are the elements that are in sets A, B, and C at the same time. Right? For example, let's say this is the set of students taking math. This is the set of students taking English. And maybe this is a set of students taking physics. Well, if I'm sitting in this overlap, it means I'm taking all 3 courses at the same time. So if you're in that overlap section, it means you're taking math, English, and physics all at the same time. All right, what about these other regions? Again, here's A, B, and C. Let me look at this region right here. And again, we're going to call A math, B is English, and C is physics. Okay. Well, if you're actually, I didn't want to draw it that way. Excuse me. Sorry. Let me erase this here. I wanted to draw just this region here. Bear with me a second. Let me fill in, whoops, let me fill in this section right here only. What about that section? Well, any student that's in that section is taking English, right? Because they're in the B circle. They're also taking physics because they're in the C circle as well. But notice they're outside the A circle. So they're not taking math. So a student in that green section is in both sets B and C, but not in set A. One more, what if I put a student out here? Let's say John is sitting out here. So maybe the universal set here, we call this S for the universal set. Maybe these are all students at the college. Well, John is not taking math, John's not taking English, John's not taking physics. John is still a student at the college, but he's just not taking any of these three courses. So John would have to be outside of the three circles. All right, so I just wanted to give you some background on what the setup of this Venn diagram is trying to show you. It's trying to show you the relationship of students that are taking math, English, physics, or even none of those courses. And each one of these different regions on the Venn diagram is a different combination of students taking math, English, or physics. Let me give you one more example. How about if I put Paul over here? Well, if I put Paul in this section of the Venn diagram, that must mean Paul is taking math because he's in circle A, but he's not taking English because he's not in circle B, and he's not taking physics because he's not in circle C. Okay, so again, each one of these regions in the Venn diagram is showing you a different scenario for how an element relates to these three sets. All right, so now let's go to this example. All right, let me mark down a few items. They're telling me that the number of elements in the universal set is 51, so I'm going to mark this as 51. They're telling me that the entire set A is 20. And the entire set B is 20 also. And the entire set C is 29. So I'm just going to mark those on the Venn diagram. Now they're telling me if you think about B intersection C, that's 8. Well, B intersection C is where the two Venn diagrams overlap. Well, B intersection C is going to be this green part right here. Right, so this green part that I just marked is B intersection C. B intersection C would be the students taking both English and physics, but not, taking both English and physics. All right, let's go to the Venn diagram here. All right, here's what I'm going to do to start off here. For set A, I know they told me this is 20. Well, that means the circle for A must be 20. So let me go to look at the circle. Well, I'm seeing here are all of the, let's call these students to make it easy to discuss. These are all the students in circle A taking math. I know altogether there's 20. Well, I'm seeing 10 plus 2, that's 12. 12 plus 4 is 16. That must mean this box has to be the remaining 4. Right? Because I know this whole circle has to be 20. All right. let me go to this part. Let me go to this part here, which I know is B intersection C. And I know this is 8. Well, there's 2 showing here. That must mean there's got to be 6 in this box. All right, now let me go look at the full circle B. Full circle B is 20. But when I look at the full circle B, I'm noticing that I've already got 4 and 2 and 6 labeled. Well, that's 12. But I know there's got to be 20 altogether in circle B. If I'm accounting for 12 here, that must mean there's got to be 8 left in that to put in that box. And I could do the same thing for set C. Set C is, what is set C? 29. So I know this is 29. Well, I've already accounted for 10 plus 2, that's 12. 12 plus 6 is 18. So if I want to know this box right here, it's got to be 29 subtract 18, which is 11. All right, there's one more box left, which is right here. So this box are the students not taking any of the courses. Well, I know altogether this rectangle has to be 51. That's the universal set. Well, if the total of all students is 51, and I want to know the number of students in this blue box here, well, the blue box has to be 51 subtract all the other students that are in the circle. So I'm just going to subtract all the other numbers I see. Well, let me write them out. I'm going to start here in circle A. It's 4 plus 10 plus 2 plus 4. And then in circle B, there's another 6 plus 8. And then in circle C, I'm going to add another 11. I'm just writing all the numbers that I see inside the circles. And notice there's 1, 2, 3, 4, 5, 6, 7 numbers. So I should have 7 numbers here. 1, 2, 3, 4, 5, 6, 7. Okay? Makes sense. And now this is a simple calculation. Let's see. This is going to be, I'm going to try to do this in my head. 14, 16, 20 plus 14. That's 34 plus 11. If I add these numbers up, I think I'm getting 45. So that leaves 6. So in this box, I would put a 6. Okay, so again, it's kind of a little bit of a, a logic puzzle, so to speak, because you want to be able to figure out what numbers belong in the missing boxes, and by kind of a process of elimination, you could do that and use the given information to kind of isolate the unknown quantities. Okay, again, there's a good video in the lecture that shows you some similar worked out examples to this. All right, let me go and see. How about if we look at number 12 here quickly? It says search using a search engine for the word asteroid was 24.9. Search for comet yielded 93. And both was 3.8. How many websites contained either asteroid or comet? Well, really what they're asking me for is the probability of asteroid or comet. Well, I can think of that as, I'm sorry, this should be an N. I can think of it as the number of websites that had asteroid plus the number that had comet. Then I've got to subtract out the number that had both. All right, this is kind of like a union symbol here, and this is like an intersection here. So they give me the numbers here. This is 24.9 with asteroids, 93 with comets. and minus 3.8 here for both. So you could just work that out on a calculator. All right. How about if we take a look here? All right, let's look at number 14. Number 14 is kind of similar. So you remember, I'm going to write down the formula again one more time. It says if you want to know the probability of, not probability, I'm sorry. I'm thinking ahead to probability in later modules. We're talking about the cardinality here. So the cardinality, by the way, there's a similar probability formula that we're going to talk about. Looks very similar to this. But right now we're talking about cardinality. So sorry about that confusion. So the cardinality rule says if you want to know the cardinality for A union B, it's the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. But you can think of the word union relates to the word or. So I can really think of this as A or B. And for intersection, you can think of it as the word and. Remember, if you're talking about the intersection on a Venn diagram, those are the elements that are in set A and in set B at the same time, right? So intersection is that overlap, and it's really the word and. All right, well, now I can kind of plug in. It says there's 14 desserts that are yogurt, fruit, or both. So this is really giving me 14 for this number. Here's the number of yogurts. There's 8 of them. Here's the number of fruits. There's 9 of them. We want to know how many desserts with yogurt also have fruits. Well, that's really yogurt and fruit together. So they're asking you to find this quantity right here. Again, this is a little algebra that you can work out. All right, let me do maybe one more example here. Let's take a look at a table. All right, so here's a table, and I could see they're labeling the rows and columns here. So this is 100 stocks after 1 year. So there's pharmaceutical stocks, there's electronic stocks, there's internet. The stocks either increased or were unchanged or decreased. So these are the number of stocks showing up in the table. All right, here's what they say. Use symbols to describe the set of non-pharmaceutical stocks that increased. So to be in this set, you have to be a non-pharmaceutical stock and the stock also had to increase. So this is really an and kind of combination, but and is really an intersection. All right, well, non-pharmaceutical stocks, I know pharmaceutical stocks are labeled as P, but I want non-pharmaceutical stock. Well, that must be the complement of P. So the complement of P is the non-pharmaceutical stocks. The word and goes with a intersection symbol. And now I want to know the stocks that increased. Well, they use the to indicate the set increase. So I want P complement intersection V, so here it is. All right, now they want to know how many elements are actually in the set. Well, for that, I could go to the table and do some analysis. I know I only want to focus on the stocks that increased. So let me go to this row only. I just want to focus on this row. I'm not going to even look at these other rows because I'm only interested in stocks that increased. All right, now I also want to know the elements in this set have to be non-pharmaceutical. So I'm going to cross this out because I need non-pharmaceutical. Well, that only leaves 5 and 15 left. Those stocks are the stocks that belong in this set. So the answer here is 20. Okay, so the key of this problem is recognizing that the set they're describing is really an intersection, because the set has to be the set of stocks that increased, and they also have to be non-pharmaceutical stocks to be in the set that I'm interested in. All right, maybe I could do one more example here. Let's take a look at one more example. All right. So now, again, they're giving me a table here. Let me make sure I understand what this table is telling me. The number of new houses started in different regions in different years. All right, so I can see here the years 2012, 2013, 2014. Here are the different regions: Northeast, Midwest, Southwest. Okay, so I understand the table. All right, use symbols to come up with the set. Housing starts in 2013 in the West and South. All right, so I need housing starts that were in the year 2013, and they have to be in the West and the South. Now, when they say West and South, they really don't mean the intersection there. I got to be careful. They really mean the West or the South, right? Because a house can't be in the West and the South at the same time. They really mean they want it to be the year 2013, and it's either a housing start in the West or the South. All right, well, the year 2013 is B. I want that to intersect with the West or the South. That's W union S. So on B, intersect W union S. So it looks like it's this answer right here. All right, compute its cardinality. So I'm going to go to the table and figure out how many housing starts belong to the set. Well, I know they're asking me about only the year 2013, so I'm only going to look at this row. Forget about this row, and forget about this row. I'm only looking at 2013. And they have to be in the West or the South. That's these two numbers. I'm going to cross this out, cross that out. So this set looks like 330 plus 130, which looks like 460. So 460 is the cardinality. All right, folks, hope this helps as you're getting started in the web assigned homework. Please let me know if there's any questions.